Also, please note that not only these weights are between 0 and 1, but their summation adds up to 1. So if we add up these weights, okay, let's compute 1 minus b minus a plus ab, this weight, then plus b minus ab, then plus a minus ab from here, and then plus ab. Okay, so if we cancel out these terms, okay, this goes, and this goes, and this goes, and this goes. You can see that their summation also adds up to 1. So all of these weights are between 0 and 1, and their summation adds up to 1. So this will give us a weighted average of the 4 texture colors that surround the actual texture coordinate that we want to sample from. So there are other types of interpolation methods during texture mapping, but in this class we will only need to implement bilinear interpolation and nearest neighbor interpolation. And remember, in the nearest neighbor interpolation, so let's also write the formula for that. It's a very simple one. In the nearest neighbor interpolation, the texture color is computed as simply fetch. We are going to round I, and we are going to round j. So we take the color from the nearest pixel value. So one thing to be careful about when you do these things are make sure that when you round or when you access the next element, you don't access out of bounds of your texture image. Okay? In general, if you need to, let's say k plus 1 takes you to an outside value, simply clamp it to the border. Again, in computer graphics, in texture mapping, there are different clamping methods. But in our case, it would be sufficient to clamp the out of bounds accesses to the nearest border.